This problem asks us to take the derivative of a fraction that has a function in the numerator and another function in the denominator. The quotient rule for taking derivatives says, if we think of the numerator as being a function f and the denominator as being a function that we call g, then the derivative of that fraction is f prime g minus f times g prime divided by g squared, where the primes mean take the derivative of that particular function at that moment. We'll begin by taking the derivative of the numerator. Secant x to the fourth can be done with chain rule, 4 times the secant cubed of x, and then doing chain rule, the derivative of secant is secant x times tangent x. Note that the derivative of cosecant of 2, since cosecant of 2 is just a number, becomes 0, so we can ignore it. Then we multiply by the function g, x cubed plus 1 plus 2. We'll then subtract the next part. The function f remains as is, secant to the fourth of x plus the cosecant of 2. And we multiply that by the derivative of the denominator. If we think of that denominator as being x cubed plus 1 to the 1/2 plus 2, then when we do the power rule, it's 1/2 times x cubed plus 1 raised to the negative 1/2, and then by the chain rule we take the derivative of that x cubed plus 1, which is 3x squared. What's left to do is to take the denominator and square that function. No derivatives required at this point, and by the time we're done with that, we've completely finished doing the quotient rule, giving us the answer to the problem.